Welcome to today's session. And I can see now that with the week going by, there's some familiar names that keep on coming in, hang in there. And for those who are joining us for the first time, also welcome. And without wasting any time, Caspar will do the house rules and hand over to Dr. Host for a presentation. Thanks.
Thank you so much, Cabela. Welcome everybody to today's session, the third unit of M1. We only have a few small house rules for today. We'd like to ask everyone to please mute your cameras to save data and bandwidth. Also to mute your microphones to keep all the background noise to a minimum. If anybody has a question at any point in time, please feel free to raise your hand, or you can put it into the chat area if you're experiencing some mic problems. Then over to you, Dr. Gous.
Thank you very much. Thank you. I'm just going to put my phone is on silent so I don't get interrupted. Awesome. So as Cabela says, hang in there. We've got one more session to go on M1. And it's really good to have you with us. We are very aware of the impact of load shedding in this country. So let's go. And we've got a recording. So for those who are watching the recording, it's great to have you watching us, but it'll be great to have you joining us as well. So today is really about, and on the one hand, we've got the engineering, so we build a robot. On the other hand, we program the robot to make it move. But in between is what we call the 21st century skills. And the 21st century skills are like problem solving, collaboration, teamwork, imagination, innovation, creativity. And so these are all the 21st century skills that our learners will develop. And then you as a coach will develop with your learners. I prefer to think that you can't teach problem solving. You can teach techniques of problem solving, but usually in the application of techniques. It's like the brainstorming, drawing pictures, sketching, and lots of color. I always enjoyed with teams of learners. If you have Koki pens and pencil crayons and big pieces of paper, you need to be able to draw over your middle line. A single piece of paper, an A4 paper is fine, but it certainly is very limiting. If I say to you, solve the problem on this piece of paper, then that's it, all right? But if I give you a whole roll of paper, or I give you like those big desk calendars we used to have, I don't know what happened to those, but we don't seem to be getting those anymore. But that is also an option for thinking a bit wide and a bit out the box. Is you can do some problem solving. And the good thing with problem solving is you always have a problem. The sad thing is a lot of learners don't take time to understand what is the problem, okay? And once you understand the problem where you are, then you can reach your solution just that much quicker. And so one of the cool things one of the things I like to do is to say, use a piece of Bostik and attach it to the side of your robot and let your robot draw a letter of the alphabet. That was last year's task, and we had some amazing submissions. I think we've got the whole alphabet. I'll let you know which letters are missing. But I do think we need to do a production on that because it shows that everybody had a different way of solving a problem. So even if my name starts with a P and Cabela's surname starts with a P, and I will maybe draw a P going straight up and then like that, that's the way I solve it. Cabela would maybe go like that and the other way around. They're both solutions to the same problem, all right? And if my P is that big and Cabela decides to kind of draw all over the place, that was not part of the specs. I didn't say for the problem, all right? So with robotics, there's that thinking, like, how would I do it? And I also add that part of problem solving is a little bit of drama, a little bit of acting. Then you can think, okay, so how do I solve this problem? All right. But I'm going to get you to talk with me through it. So I'm going to do a very short presentation, and then you can think, okay, so how would I solve that problem? All right. So let's quickly, this proverbial, let's share my screen. I'm sure there must be a different way of talking about it, but anyway, let's have a look. All right, so you can see my screen, yes?
Yes, Dr. Gous, we can confirm.
All right, and you'll watch the lobby. So here we are, it's Wednesday, we're on Unit 3, we're doing some problem solving, and so Yay, we've like come halfway already. Okay, so you've heard Cabello, Anzani. I don't know, Tumelo might have load shedding, and then
No, I'm here. Don't worry.
are you here? Awesome. Happy Wednesday, Tumelo. Great stuff. It's good to hear a voice behind my screen, but it's lovely. So I think the navigation information you most of you have got. But Tumelo and Anzani are in the mailbox permanently answering all your queries and emails, and we'd love to hear from you. So even if you just want to say hi, please send us an email and just say hi. That'll be also fine. Okay. So unit 3 of the amazing race, and you are all survivors, and we're getting there. We're getting there, and we're building robots, but we've got to keep going, and we'd love to hear your questions and answers, because we want competent and confident robotics coaches, so we can have competent and confident learners as well. All right, so what we've got, when I've put problem solving in bold, because that's what we're going to focus on today. You're probably going to use some creativity and innovation as well, and a bit of imagination. But that is what we're going to concentrate on today. So we're assuming that you've got some software installed on your laptop, and you've got some robotics kit, whether you have access to a robotics kit at the local science center, or in your classroom, or whatever you have. Let us know. Maybe let us know. Send Anzani an email and tell us about your robotics kit that you currently have, or maybe wish to have. And then you must have some software. So either EV3 class, which is the Spike, or the Spike, the Scratch, or the Spike Prime. Okay, and so these are the 2 robotics kits that we currently use in our classes. The Spike Prime is the colorful one, and the EV3 is all the grays and blacks and whites. Okay, so let me talk about navigation. Navigation, a robot has to be able to move, all right? And in our case, the robot will move because it has wheels. Okay, to make the robot move without you actually touching it, it means it has to move autonomously. To make it move autonomously, it must be programmed to do so. All right, and so here you've got the robot you've built in Unit 1. You've got the programs that we were introducing yesterday. So now we actually need to solve a problem. Okay, and if you go onto the internet, you'll find other definitions of robot navigation, because it becomes quite a complex topic, because in most navigations you use sensors. All right, so a robot that goes forward will then have a sensor to say when it's going to bump into something, when it's going to fall off the table, when the light changes. So that is when your robot uses sensor data. Okay, so odometry is also linked to navigation. So that's the data that the robot gets from its environment. And then there's a lot of robot navigation techniques that you can use. Okay, but what we've got now is we've got autonomous robot navigation, and we've got a senseless robot. So our little robot does not have any color sensors. It doesn't have any ultrasonic sensors. It doesn't have any touch sensors. It's just a little robot. Okay, so on that little robot, because we don't have sensors, we need to measure. We need to measure to get, and it's really important that learners grasp that what you tell the robot to do is what it's going to do. Okay, and because it doesn't have sensors at this stage of the lessons, you've got to tell it exactly what it has to do. All right. So for problem solving, you need to be able to identify what are the steps towards your solution. Okay, so normally you define the problem, but you've got to define the problem using the information that you have. All right, and then from there you decide, okay, so what are the possible solutions that we could use? I really want to encourage you as coaches to hear every learner's suggestion. All right, it's no use taking the kid that puts his hand up first and say, okay, that's an awesome solution and let's go with that. No, let us listen to everybody's solutions. I think there's somebody's unmuted. Just hear an echo there. And then you can implement one or more solutions, and then you test it. So whatever you're doing, you have to be able to arrive at a solution without saying, oh, he suggested it, we did it. there needs to be that teamwork. All right. Problem solving skills are really important because they develop over time. All right. If you keep teaching your learners the only way to answer their maths questions is to look at the answer in the back of the book. No. Okay, because the maths answers at the back of your book might not be correct, number one. And number two, life is full of problems, and there is no textbook, and there are definitely no answers to life's problems. So you have to develop skills for problem solving. And so the steps, you've got to start somewhere. So the first thing you've got to do is you've got to say, okay, so what is the problem? What's the definition of a problem? And then the techniques of solving problems. There's quite a lot. So just there's no ultimate technique. All right. You need to apply it within your classroom. But if you go online, go and look at techniques for problem solving, you will see that it varies. Obviously, if you are sitting with, say, grade ones and you're doing problem solving, you can do lots of diagrams and pictures and discussions. No, maybe everybody can do that. Yeah. All right. So in Unit 3, there are some activities. Okay, so these are just general kind of activities. How would, so now you, Tumelo and Kabela and Casper, you must watch. How would you draw the first letter of your first name? Explain to me, what are the steps? Anybody? Anybody? How would you draw it? Well, first of all, you'd have to stick a pen on the side of the robot. Then you'd have to decide what is the first letter of your name. Then you go with your finger and say, okay, so how does the robot go forwards and backwards to draw my name? All right. And if you are doing, say, well, L is very easy. L goes straight down the letter and then has to turn. That is the first letter. Okay, so how far? So if it's 4 rotations down, then it must be 2 rotations. These are all the things that you need to talk through when you get to a solution. If a robot must move in a square, say around a shoebox, all right, or it must move in a rectangle. A rectangle has 2 sides that are shorter than the other 2. Okay, if a robot must move in a circle around a bucket, then it must keep turning. Then it will never move straight because a circle doesn't have a straight side. Okay. But you need to be able to talk through these, and we'll get back to it afterwards. You need to be able to talk through these problems to get to a solution. And look, we haven't even started building a robot or programming the robot, but you need to be able to talk it through and say, okay, so what do we have? All right. The thing about problem solving, although it's a 21st century skill, it needs practice. You need practice, practice, practice. And then I've got the other P words of patience and perseverance. And I've got teach there in inverted commas because I don't think we teach problem solving. I still think we develop problem solving skills. Definitely the learners in all the teams that I've coached, they definitely have developed problem solving skills. All right. But it has to be practical. You have to be able to talk about it and discover the solution. You cannot memorize it. You cannot memorize a solution, but you must have an understanding of what the problem is. Okay, so what is given, what can be observed, what is required, and then define the solution. What is for you success? Okay, and then of course that's where you want to get to, but where are you where you start? Okay, so where are we? Well, we have a robot, and the robot can move, and we understand navigation. Great. And in inverted commas, we are not using sensors. Just in case you think we can maybe use sensors. No, we're not using sensors today. We're going to do that. All right. So let's start. We've got to decide what is given, what is known, and what is required. And remember, we're only doing navigation for wheeled robots. Okay. So we know where the robot starts, we know where it ends, and we've got it. Okay. So this is a problem-solving methodology that I learned from my friend Tanya Karp when she was here as our Fulbright scholar, and it's called Solvum. Solvum says we sketch it, we identify the objectives, then we make lists of the variables, the numbers we know, and the equations we know, or how the calculations work, and then we manipulate the whole thing. Ta-da! And then we can. There's a a link as well to think like an engineer. Okay, so here's our first problem. The problem says move straight a given distance. Okay, so if you draw a picture, you can say, okay, we start here and we end here, and that's a distance. Okay, so the robot must just move. Okay, but I didn't say if the robot must go forward or backwards. I didn't say how fast the robot must go, or how, whether it must like crawl along, or it must go as fast as possible. All right, so to move a robot, we've got to go rotations. Okay, now, well, the size of the wheel matters. Okay, so if you have a big wheel, you're probably going to need 2 or 3 rotations. If you've got a teeny weeny little wheel, you're probably going to need 10 or 11 rotations. So there's the difference. Okay, but then you need to stop. All right, so yes, we'll travel that distance, but then we need to stop. And here's one thing. I showed it yesterday. Was it with us yesterday? I can't remember, about how to determine the size of your circumference. You can do a maths calculation. Yes, you can. But you can also take a piece of ribbon and then just measure it and then put it on the ruler, and then you see how long it is. Okay. So here we've got our variables. We've got distance traveled. We've got to travel 50 centimeters. The circumference of the wheel, which I then measured with a piece of ribbon, was 17.8. And then we can do a calculation. Remember, we've got distance, we've got circumference, so we can divide. All right. So ching, 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 we've got an equation that says circumference times number of rotations gives us distance. So then if we manipulate it around, we say, so if we've got distance divided by 17.8, we've got 2.81 rotations. Great stuff. Okay, so just if you're going to use move steering, you're getting both wheels moving at 20% power, 2.81 rotations. Okay. However, if you're going to use a move tank, you must have both wheels at the same power setting. Otherwise, it's going to veer off onto the left or the right. Okay, so I have warned you on that one. Okay, then it's done. Okay, so now we're going to say, okay, so learning from what we've done, here's the next problem. It says determine the relationship between power and speed. Okay, so power and speed, we see a graph. Yes? Okay, so if we can change the power, can we change the power level? Yes, we can change the power level. So that is your independent variable. Your speed is your dependent variable because your speed depends on the power level. All right. So if just flick your brain into like common sense and logic. If you put your foot down on your car, the more power you give your car, the greater the speed. Yes? All right. Okay, so now we've again got a start, a stop, we've got a distance, and then we've got a time. All right, now we're going to solve the problem. All right. Again, we can't really measure speed, but we can measure time and we can measure distance. And we know distance. All right. For the junior learners, I think that the topic of acceleration, deceleration, maybe just don't ignore it, but just for the senior ones, we can probably develop another where we have a run up and an ending. But let's just assume that it starts at the same. Maybe don't let the robot go too fast. Okay, so the acceleration doesn't have such a huge impact. All right. And then we've got to repeat it because we've got different power settings. And we think that we are assuming that the speed will increase with power levels. All right. Okay. So we've got a distance and we've taken 1.5 meters. We've got a circumference, which is 17.8. And here, titting, this must also be a warning to you. That's in meters, that's in centimeters. You've got to get it in the same measuring unit. All right. So please remember that. Okay. Then we have number of rotations that we can calculate. The power levels we can change. Remember I said that was the independent variable. The time, well, everybody's got that on their phones or if you've got a watch. And then the speed you can calculate by using time and distance. All right. So here we go with our calculations. If we're going to go 150 centimeters, which is 1.5 meters, divided by 17.8 centimeters, we've got about 8.43 rotations. All right. Now we set up, I love tables. All right. So now we say, okay, here we go. We set the power level to 10. We let it go. We measure the time, we calculate the speed. We set the power level to 20, we let the robot run. Then we go, how long did it take and what was the, calculate the speed. And so you calculate it. And I thought maybe I should give you the answer, but I'm not going to give you the answer. And I'd love to hear from you if you've done this little exercise. Okay, so there's a whole range of navigation problems, like move forward, turn, stop. How long does it take to get to there? Can you calculate exactly how long it's going to take? And then whether you go forward or back. But each one can be solved systematically, and ad hoc is never recommended. Measure, work it out, and document it. Right. Okay, so that's one level of kind of problem solving. It goes to another level, and actually I need to bit before problems, the missions on a challenge. Before that, we did a series of projects, and I think we need to do some projects again. And they are small problems, individual problems. So how do you make a robot move like a cockroach? Right, so that would be a cockroach, as soon as you shine a light on it, it stops, turns around, and goes in the other direction. How do you get a robot to move like a frog? You stop and then moves forward, and then stops and moves forward. So that's the jumping, mimicking the jumping of a frog. Okay. How do you make a robot detect if somebody walks past? So that'll almost be like a beam that you have. How would you do that? How do you program it? What structures do you need on your robot? All right. So that's the one part. And that is if you have a single problem to solve. It gets a bit more difficult if you have a whole lot of missions on a robotics challenge, all right? Because then what you need to do is you need to unpack each of the missions, okay? Lots of paper, lots of thinking, or select some of the missions that you think are doable and then solve them. And if there's time, you can do some more, but yeah, so there is one thing. The other problems is building. So you want to build something, but you're not sure exactly what to build. So for that, there's the resources of building instructions. And building instructions, I highly recommend that learners use building instructions, and then we modify them. Okay, whether you're building a chassis or whether you're building an attachment, build from building instructions first, and then you can modify it. Okay. It's kind of the same with programming, because there's lots of examples of programming examples. It is a good habit for learners to be able to read code, all right? So if you find some examples of code, maybe show your learners and say, read this, tell us what this robot will do. The cool thing is if you can just download that code onto a robot and then do it. So maybe before you download it, maybe just read the program and see whether it's what you wanted to do. All right. Then there's online tutorials, quite a few of them. And I also want to just add that we are busy making a list of how do I then solving problems. And so if there's any specific thing that you want to know, maybe send Anzani an email and say, how do I? And then we're going to make very short little videos, and maybe we can help you then just solve that problem. But a really cool thing would be if our teams can solve their own problems and then share that. Yes, there are YouTube videos. Some of them are quite long, but we're trying to find a series of very short videos. How do I? Okay. Okay. So problem solving, there's a lot of literature about problem solving skills and how robotics kind of supports the development of problem solving skills. I don't want to do that we teach it, but we can definitely develop it and maybe add something to this list. I would love to have a report from you to say, how did you develop problem solving skills for your learners using robotics? All right, so maybe read some of those, maybe you'll get some inspiration there. Okay, but there's a different kind of problem solving as well in robotics. And that's more your problem to solve, you as the coach, okay? The robot doesn't always work. It's just what it is. Okay, so if you're working with a team of learners, you need to take time to watch these videos and develop in your mind how would you solve the problem. Because I can tell you now that if you're in a class, even with one team of 10 learners or teams of 20, we've got 20 learners in the class, and they say, man, my robot's not working because they're expecting you to take one look at it and say, oh, that's because. No. So what I want you to start developing in your head, at least mentally, but actually going forward, you need to have a quick checklist. All right. So one of the problems is the cables are in the wrong ports. Okay. So that is one of the structures you can see. All right. Then if the battery is not charged, that's number 2. Number 3, if you don't have sensors, well, the sensors come later, but if you don't, and then you look at the parameters in your programming, if you're going naught, and I'll show you some of those examples just now. So when you wait for naught seconds and you say, oh, my robot's not stopping, okay, so maybe that's the naught. If it's going for naught rotations, if it's connected to the wrong motors. So all these things, I've got 3 links there. If you find some more links, please share it with us. But you as a coach, well, you do need to know. And so there's a really cool debugging, whole topic on debugging and testing your robots. Maybe I should add that as well. I've got it in the M3s. Okay, so yeah, yes. All right, come to M3. How do you then debug? How do you debug? Because you've got to debug the robot, the structure, as well as the programs of your learners. And yeah, and so I also want to add, I had a team. We went to the Debrecen to represent the country at the Open Championships. Awesome. And the team put down their robot. We were doing practice runs, and the robot didn't behave. And the team automatically said, we know exactly what the problem is. They laughed about it because they knew exactly what the problem is. They put the wires in the correct port, in the incorrect ports. All right. And that is what you want. You want your learners to be able to solve their own problems and to be brave enough and gracious enough to say, we made a mistake, or we put the things in the wrong holes, and that's why the robot wasn't working. All right. But not just to sit back and say, the robot's not working. No, we need to have proactive learners who can figure this out. And so then proactive coaches that can figure this out. All right. Awesome. Okay. So we have done end of unit 3. We're solving a navigation problem. We have to solve the navigation problem. There's big navigations, little navigations. But if we can solve navigation now, I can guarantee you that the problems that we're going to pose in M3, then that'll be easier. All right. Okay. So I'm going to stop sharing, and I'm listening. I don't want to hear about your problems. I want to hear how you have managed to solve robotics problems. Anybody got anything to share? I'm listening. Anybody? Everybody's very quiet. It becomes a good habit. It is a really good habit to be able to solve problems. I really encourage you to maybe download the WRO challenge for this year. Go start with junior. Look at the challenge, look at the mat, and say, okay, so how do I solve it? You don't have to build the robot or program the robot, just as a problem-solving exercise. Okay, so how do I solve this problem? Alternatively, go and download the Cargo Connect rule book. Cargo Connect is the first Lego League challenge. Go and look at the rule book. Go and look at the mat. Go look at the elements on the mat and say, okay, so how would I solve just one mission? I'm going to ask you tomorrow. Yeah. So, and at all times, it's like, where do I start? What do I need to do? All right. Always. It's little bits and pieces. It's like eating an elephant. Not that I really want to eat an elephant, but we've got to be able to put the problems into little pieces. So with WRO, you kind of, what can you do to get the minimum number of points? Where can you, what is the it's that tipping point. What did you have to do? The WRO challenge is quite a bit more complex because you've got to build onto it. You've got to get one part right and another part right. Whereas First Lego League, you can get one mission, do it, and come back, ching, ching, you've got the points. And then another mission, come back, and you know more points. And as your team gets more experienced and develops problem-solving skills, they'll be able to do that mission and come back in less time for more points. And so that's how they score more points in a competition. And it's about, I think it's also about bundling. So where you put kind of two solutions, so the one solution kind of backs the other solution. So you've got a larger solution to multiple problems, which is even better. And what we'll do tomorrow is you build multi-purpose attachments. So that means that you have an attachment for one to solve one problem. You can use it to solve another problem as well. And then it makes your life much easier, much easier. All right. Now I'm listening. Anybody got to add anything about how then do we develop the problem-solving skills of our learners? Anybody? Is there anybody participating in any robotics challenges this year? Anybody? Oh, everybody's quiet. Everybody's quiet. Nobody. Okay, Tamela, say hi. Is anybody going to say something? Please?
Hello?
Oh, there we go. At least somebody's talking to me. Hello.
Yeah, I think that, I just think problem solving is an interesting one.
Absolutely.
Yeah, usually what I think is, especially at the FLL challenge with a team, if you can split use, what I think is when you get the season's rule book, I think the first thing to do is actually to go and give it to the team and give each single member of that team a piece of paper and say to them, all right, you guys are going to look at this rule book. You're going to write down what you think you're going to be able to do, places where you think you're going to have problems and everything like that. And then they come together as a team, and then they start and sharing their ideas and trying to find solutions for each one of them.
Exactly.
That's my 2 cents.
Thank you. Thank you. Okay, that's a good, so that's a good way of dividing it up. Dividing up and then solving a problem bit by bit. All right. So Tamela has come up with a poll, and we all need to answer his poll. And his question is anybody participating in any robotics challenge this year? Yes or no? Or maybe? If it's maybe, I can convince you to develop the problem-solving skills very quickly. Okay. Anybody? Oh, yes, yes, no, yes, no. 2 people have replied. Look on the chat. You've got to say yes or no or maybe, and then you've got to submit your vote. Anyone? You can be the coach of the team. You don't have to participate yourself. So, yes. Yes. Oh, no from Lillian. Okay. Okay, Casper's a referee. Cool. Otatile, maybe. Okay. So let me know if you decide by tomorrow, yes or no. Okay.
Hey, Istamel?
Is there a hand up somewhere? No. Okay. I think the important. Tamelo, you want to speak? I see you're unmuted.
No. I'm just typing questions here.
Okay.
So today I'm just on the polls.
You're on the polls. Okay. So maybe we should tomorrow. Maybe we should do some problem solving tomorrow. Okay, so your homework is find either the WRO Junior Challenge or the first Lego League rulebook. It's called Cargo Connect. Should I type it in the chat here? Okay, so I'm going to type in your homework. You've either got to find the first Lego League Cargo Connect, or as I'm typing, I'm sure that Casper is already finding the link for it.
I think the following question will certainly help of where to know which people we have in the group.
Okay, so there we go. Are you a coach? Are you part of a team? Are you an observer? Or you don't know yet? Please enter your thing there. Where's your focus going? Oh, still learning. Okay.
Yeah, I think problem solving is one of those things that is, once you learn it or you understand it, it helps you a lot.
Yes.
So, for example, if I look at the FLL, if I look at that rulebook, I can quickly analyze that entire document within a few minutes.
Okay, so that's the homework for tomorrow. You either have to go and find the first Lego League Cargo Connect, or you have to find the WRO Junior High and see how would you then approach problem solving. Okay.
I try to solve one mission. How do you think you're going to do one of them?
Just one mission. No, and with no sense. Oh, we got referee. We've got 2 referees already. Well done. Interesting to find out who the other referee is. Excellent. That'll be great fun.
It seems like we don't have any coaches or team or those who are just observing.
Okay, so Tumelo, we're going to change that. We're going to put this poll up again tomorrow. Okay.
All right.
Okay, we're going to discuss problem solving as an initial session. We'll get that, and then we will re-ask the poll. Okay.
All right.
Awami, are you Awami? I see Awami is observing. Okay.
Yeah.
I think if you're observing, you can volunteer as well to be an observer. Awesome. All right. Okay, and then we'll have some big discussions tomorrow about how to apply or what problem-solving techniques did you use to solve the problem of either one of those challenges. There's a virtual geared competition coming out next week, and then I'll show you how to solve that problem as well. Yes. All right. The cool thing is about problems is you develop the skill to solve a problem. All right. So for any of these competitions, if you're the coach and you take a team the first year to a competition, and you've got to really guide them in their problem solving. By the second year, you can already see you can let go a little bit, and by third year, they're well away. They know exactly what they're doing. Right. Okay. So on that happy note, I really had. Hopefully, it's been you've learned a lot. I know you're observing, but hopefully you have also maybe understood a little bit how to solve robotics problems, because at all times you must be able to solve the problem. Not only understand what you've got, but how do you solve the problem? All right. So I'm going to ask Cabello. I see Cabello's probably load-shedded again. Tumelo, can you close the session for us? Thank you. Happy Wednesday, Tumelo.
Happy Wednesday, Dr. Host, and happy Wednesday to our participants. Thank you so much once again for being part of today's session. And we really hope that today's session was very informative and going to prepare you for next week's virtual care competition for those who will be participating. Don't be afraid to email us on our email address, which is i-set@unisa.ac.za for any general queries that you might have. For those who are still learning, thank you so much for learning with us. You are at the right place with the right people in the right platform. Otherwise, thank you so much and happy Wednesday.
Thank you, team. We'll see you after tea time at 4 o'clock. Okay. Thank you, everybody. We'll see you just now. Thank you. Bye.